Hello. Hello and welcome to this video. In this video, I will show you Aggregate's example as I had promised 4 days ago. First of all, accept my apologies that I could not create videos on Postgres for last 3 days. There were certain issues, so now, as I say, that it is, I get stuck into things. So Uh, the videos are delayed. Now we will look at the aggregates example in this video, and I will probably add this file in YouTube as well as gist. I don't think we need gist because YouTube has a facility to add files. I have been ignoring that, but I will add this file as in YouTube itself. Okay. So let's look at our database. We do not have sales table, DT. So we have employees, operating rooms, and room slots. This is from range and multi-range example. So we don't need to delete anything. We can create the sales table just like so. And the sales table is created. Then we will insert some data. Okay. Now we will revisit our table. We have sale ID, which is a big serial, primary key, sale date, not null, region, not null, salesperson, not null, product is not null, quantity is not null, and the quantity should be greater than 0. Unit price should be not null and greater than equal to 0. Discount should be not null, default is 0. Check is there that discount is between 0 and 100. Rating is 3, 1 and return is boolean, not null, default false. Okay. So now we have this data where these are the third column is salesperson, I believe. Yeah, third column is salesperson. So we have this data. Okay. Now when we do, let's verify that we have 12 rows inserted. Select start from sales. So we indeed have 12 rows. Now, when we want to count all rows, then we do count star. Note that it's a very bad idea to do count star, particularly on large tables. On large table, you should never do count star. Don't try to count rows on a large table. Then we want to count ratings from sales. And you see it gives us 11 because rating for one of them is null. So it will count only non-null ratings. Now we want to see that how many laptops were sold. 72 were sold. And let's look at the revenue. So we have the formula here for the final price, quantity into unit price, 1 minus discount upon 100. That will be our sum will be total revenue. So that we can do, we have 1,459,710. Now we can calculate average, minimum, maximum, those things we can calculate. So let's calculate that. And we have average price of 43,625, lowest is 3,500 and highest is 85,000. We can also find out the average rating by using the average aggregate function, which is 4.36. Now if we want to group by region, then we select region, we select sum, the same formula for revenue, and from sales, and we group by region and order by revenue descending. So let's see which region tops the row. South region is the winner, east is at second place, and north is at last place. And the revenue is also there. Now we can have multiple aggregates in one query. We can have count star, we can have sum quantity, we can have average, min, max price, revenue, and we can group all this by region. So quite a bit of things to do. So we have that. Also note that I said about count star for large tables is very expensive. That is also true for sum, average, min, max, because it has to go through all the rows. Okay. So if your table contains millions of lines or more, then you have got a problem. Okay. You need to figure out different ways on how to compute that. Particularly in this case, for example, materialized view will be best solution because materialized views are not updated all the time. So we can refresh that periodically. For example, we can do count of sales using a materialized view. And when you query it, you might get stale data, that is true. But it is inexpensive and the background calculation can be done on count star. Say, for example, you have this kind of sales across the regions, right? So you would have some central database where the rows are being placed all the time. So during daytime, you don't touch it. And let's say at 9 p.m., the stores are closed. So you can run the queries for materialized view and update the view, say at 10 p.m. or midnight. So that time your database is not loaded and it can perform the count star, sum, average, min, max, and all that for the entirety of database and update the view. So expensive queries are best run as jobs when the database is free. This is also true for things like banking applications where you want to figure out how much money went in, went out, and other metrics which you want to account for. So now we see count star as total sales, then we can apply filter. We have not yet studied filter, where return is equal to false as successful sales, where return is equal to true as return sales. So let's see this. So we have one return sale and 11 successful sales. Now we can find out the revenue from the return sale. So, sorry, filter select, this is the revenue filter where return is false. So from non-return sales, that is only sales where the laptops were not returned, we want to find the revenue. Now we can find out people working in different region. We can group by region and order by region. So you can see that Meera and Sanjay are from East Zone, Amit and Priya from North, and Neha and Rahul from South Zone. So if you want to do array aggregation, you can do array aggregation like so. We are doing this on product, okay, and distinct products, that is, and we are also ordering by product, and here we are ordering and grouping by region. So let's see. So from each zone, keyboard, laptop, monitor were sold. So from all regions, keyboard, laptop, and monitors were sold. So you see how we select them as array. Now we can do the same thing for JSON aggregation as well. So you'll get JSON array this time. So we have got whatever we queried for in the form of a JSON array. Okay. Now we do statistical relationship. So for example, correlation between discount and quantity is computed here, and that is minus 0.51. Honestly, I don't know the meaning of that. It has been quite some time since I studied correlation. Now we calculate average rating and standard deviations of the sample. So standard deviation is 0.329 and average rating is 4.36. Similarly, you can calculate population variance and sample variance of prices. So I think I'll stop here. You get the idea. So the queries are self-explanatory. For example, let's go all the way to end and see some complex ones. So for example, we want a dashboard query for our, say, management. We have count star, we have sum of units sold, we have the average product price, we have the min, max, and then we have gross revenue with the formula. and we have net revenue where we don't have return one, and then we have returns, and we have average rating and median product price. Okay, so let's see this for our, let's say, CEO, then C star out. So we have that, and we have this return result, which we can show in a very nice dashboard for management. The other thing could be we are demonstrating null behavior of aggregates. There are no sales for the West region. Some returns null when there are no input rows. So see how a region is West. So we will have no output here, and we will have no output here as well. But we are coalescing. So since we are coalescing to 0, we will have 0 in the output. So there we go. So that was the example of coalesce. And let's look at this one also. So this is regional sales report. The one we saw was overall. And if you want the same thing in a region, you can do that, and you have a regional report as well. So I'll attach this file in the YouTube video itself. You can download it from there and play with it. And if you have questions, let me know, and I'll try my best to answer your questions. Although if your question is quite long or requires a long answer, it is best if you can come to this website where I have created a question answer application for you, and ask your questions there. Use SQL or PostgreSQL there for tag, and create a login, and I think delete this. Okay. So let me put this as part of the file. Okay, create login here to get answer. Okay, so you can create a login here and ask questions whichever we have, and if you have ideas about what other feature you might need, make sure to use the issues in the GitHub of the repository. The GitHub link is in the website. So create an issue in the GitHub, and if your requirement of any feature or improvement is of importance, I would most definitely implement that. So thanks a lot for watching the video. We will most probably, I'll make the next video tomorrow, and that will be on window functions. So that is another very important video. And after the window functions, I should be able to complete that. Let me see. Okay, Ocular downloads PostgreSQL, and we have window functions, right? Let me see how many pages are there. So, oh, okay, only one page. All right. We should be able to finish this window functions, and the example also I will have ready because it will be a very small example. So I will complete window functions tomorrow, and then we will move on to merge support functions, which is also very small. So these two, I think we can cover tomorrow. Section 9.22 and 23 we will cover tomorrow. So with this, I will take my leave, and I hope that you have enjoyed this video and learned something from this. So I'll see you in the next video, possibly tomorrow. And thanks a lot for watching the video. Keep learning, stay curious, and most importantly, enjoy.